So a continuation along with our journey here in terms of relations, we have to look at a specific type of relation that we're going to call a function. Now, before I get into the definition, and there's a ton of definitions in this podcast, so you got to be careful. I'm going to give you an example. The best example I can give you is this. Let's look at your class, for example. And then notice in your class, there's people of a variety of heights, right? They're all different heights, but there are some people in your class that are the same height. Let's take, for example, Bill and Bob, okay? Let's say Bill is 5 foot 11 inches. Well, let's say Bob is also measured out to be 5 foot 11 inches. Okay, so that's how tall they are, right? Okay, with that in mind, think about this. This is what we're going to end up calling a function. Because for every person out there, you have one unique height that's related to the person. But sure, you can have two different people, Bill and Bob, be the same height. That's fine, right? But I got a question for you. Can Bill, who we know is 5 foot 11 inches, can he also be 6 foot 1 inch? Well, of course he can't. He can't be two things. This would be considered not a function. See how this works? Two different people can be the same height, yes, but one person can't be two different heights. That's impossible. Okay, so before we go on, let's start talking about some key definitions, and they're down here. Okay, one of them is called domain. I like to refer to domain as the x values. So what do I mean by that? Think about x and y axis. Think about graphing. The domain are the x values of the xy axis. The range then would be the y values. But wait a second. What would happen when we're talking about Bill and Bob here? Okay? Well, Bill and Bob are what we call independent variables. Why do we call them independent? Well, Bill and Bob are two different people, aren't they? And out of your class, how did I choose just Bill and Bob? Well, I randomly chose those two people to represent the entire class. That's why we call them independent. There's no strings attached. I said, choose Bill, choose Bob, we're good. But now let's look at the y values. The y values, or what we call the range. These are the set of all possible values for the dependent variable. Now, what do we mean? Okay, well, think about it. As the independent variable, so when I chose Bill or Bob, right, I said, Bill, oh, let's measure, 5 feet 11. Well, this means that depends on who you choose. See what I mean? The range just means who did you choose, or the domain means I'm going to choose Bob here. The range here says, well, depending on who you choose, it's going to spit out an answer, and the answer is 5 foot 11. See how it works? So basically, by choosing different people, you will have a different result. So these are the people you choose. This is like the result as because of the people you chose. You see how it works? Okay. So if I was to choose, let's say, Kathy. Let's say Kathy's 5 foot 2. All right. So, okay, I just chose Kathy. Kathy is my independent. I chose her independently, no strings attached. And boom, this spits out 5 foot 2 inches, which means that's how this depends on who you choose. You see how that works now? Great. So let's go now to the function idea. A function is a relationship in which each value of the independent, so in other words, all of these values that I chose here for my domain, is associated with one value of the dependent. So in other words, Bill can only be 5 foot 11. He cannot be 6 foot. See what I mean? Okay, so in simple language, it says right here, for every value in the domain, there's one unique value in the range. So now let's go back to this and let's actually sum it all up. It says a function is a special type of relationship where each element in the first set, which we call the x, the independent, or the domain, has is associated with exactly one element in the second set, which we call the y, the dependent, because again, it depends on who you chose here, and this being the range. You see how it works? Okay, so let's look at a nice example over here, and I'll show you how all of this gets associated together. Here we go. Here's a great example. Okay, so you have in your X category here, you have, of course, this being your domain or your independent. So in other words, I'm choosing who I want to represent here. So I've chosen a human, I've chosen a whale, and I've chosen a horse. But one thing that's kind of unique to all of these three guys that I chose is that they're all mammals. Every single one of them is a mammal. So again, you can have three things pointing to one thing, but you can't have one thing. For example, you can't have a human pointing to a mammal and to an insect. That would not be a function. Well, of course, a human's not an insect, not even in Hollywood. Oh, well, maybe in Hollywood. But anyways, so being that they're all choosing or all dependent and they're all mammals, okay, we say that this is, in fact, a function. Look at an example that is not a function. For example, if I go over here, right, things you want to look for, simple arrow going this way or an arrow going to two things. That's fine. But look what you don't want. You don't want an arrow from here pointing to two different things. Always think of the heights. You can't have an arrow pointing to somebody who's 5'11" and 6'1". It's impossible. So this is not a function. Let's keep on going. Let's look at a few more examples and we'll see what we can do to clarify this. Look at this. The number of wheels on a bike, car, motorcycle, tricycle, unicycle. So here's my domain, 1, 2, 3, 4. Now, is this a function? Well, so far, right, you got one unicycle, that points to one thing. But look, 2 can't decide. It's either a bicycle or a motorcycle. So guess what? Automatically, not a function, right? But now let's look at the reverse. Here's a bicycle and here's a motorcycle. You know both of them are going to choose to be 2. This is like having 2 unique people in your class having the same height. That is, in fact, a function. See how it works? Pretty darn cool, isn't it? So, with that in mind, I think we're good to go. I think you kind of got an idea of how to describe functions.